Hello, everybody. My name is Andy Rivenis. I'm a product manager for Database InMemory. So today what I'd like to do is give you a brief introduction to what Database InMemory is and a little bit about how it works. So why use Database InMemory? Database InMemory is focused on improving reporting performance. It's not going to speed up OLTP per se. We're really targeting reporting performance, being able to scan and filter a lot of data very fast. It can be a very useful tool in providing a good performance improvement for reporting without having to change your existing SQL or your applications. In addition to that, we talk about real-time analytics. And what we mean by this is being able to run your analytic reporting right on the source data. So not having to wait for data to be ETL'd to a data warehouse or a decision support system, but being able to run ad hoc reports or analytic type reports and be able to drill down into that data right on the source data without having to wait for that data to be moved somewhere else. This can give a significant advantage to a business being able to mine their data in real time for real-time business intelligence, if you will. In addition to that, reduced overhead. So typically, folks have had to add quite a few analytic reporting indexes to their row stored data in order to get those reports to run efficiently. With Database InMemory, we don't access indexes during in-memory scan, so very often you can eliminate those analytic reporting indexes. Now, I'm not talking about constraints like primary key or foreign key constraints, maybe lookup indexes that if you have a lookup table, use an index just to get a one or a very few number of rows. Not those indexes. Typically, you'll certainly want to keep your indexes that are enforcing constraints and your lookup tables, but very often a lot of the indexes that are part of an application are actually targeted at analytic reporting, and those you can typically eliminate, and that can free up a significant amount of resources, both in terms of the disk space required to maintain those indexes, plus the workload during transaction processing, undo, redo generation, CPU overhead to maintain those indexes, can lead to a significant capacity increase by not having to have those indexes maintained. So those are kind of the areas that Database InMemory targets. So let's talk a little bit about what it is, how we implement it. And I've spoken a little bit about the real-time analytic aspect. Accelerating mixed workload means eliminating analytic reporting indexes. Database InMemory is part of Oracle Database. It's fully integrated. It was released in 12.102 as part of Enterprise Edition. So all of the existing Oracle technology works with Database InMemory. In addition to that, since the choice to use Database InMemory is a optimizer decision, you don't have to change any of your application SQL to take advantage of it. And that's a big win for a lot of customers. So Database InMemory is actually a new memory area we allocate in the SGA. And what we do is we populate data in a columnar format. So if you have data in the row store or your traditional row format, you just enable those tables to be populated in the column store in columnar format. We'll populate asynchronously in the background. We'll keep that data simultaneously and transactionally consistent, very similar to the way we keep an index up to date. So we preserve the Oracle transaction architecture, both from a read consistency point of view. You'll never get data that's not read consistent, whether we access it in the row store or the column store. In addition to that, you don't have to populate the entire database into the column store. You get to pick and choose objects, whether they're tables, partitions, subpartitions, or materialized views. In addition to that, we run on anywhere Oracle Database Enterprise Edition runs, Database InMemory can run. So you don't have to have Exadata, you don't have to have a specific hardware to take advantage of Database InMemory. And it's very simple to implement. One initialization parameter, the in-memory_size parameter. We allocate that area out of the SGA, and then you just simply alter a table, as I said, partition, subpartition, or materialized view to be in memory, asynchronously in the background will populate that data, so the database itself isn't affected. We don't have to wait to start up the database for data to be populated. It can happen at any point in time when you alter a table, or at startup if you set a priority. And then later you can drop your analytic reporting indexes, possibly to speed up OLTP, since you don't have to maintain those analytic reporting indexes for transactions. So how does database in-memory work? So traditionally, Oracle databases have been a row formatted database. And I mentioned columnar formats. The columnar formatted data or databases has been around for a very long time. So row-based database is great for transactions. All of the information in a row is there in memory to operate on. But in order to run analytic reporting against row-based databases, we have to look at a lot of data. You have to get each row, navigate to each of the columns you're interested in, and that requires accessing a lot of data. Whereas columnar formatted databases, columnar data, it's very easy just to access the columns that are part of the query. We can scan that data very quickly. Typically it compresses well, and so there are other optimizations that make that data very easy to access for reporting. However, for transactions, it can be quite expensive because now you have to reassemble the rows, the column values for each of the rows back together in order to do transaction processing, something we call stitching those rows back together. And that can be very costly. So until now, you've had to choose between row-based or column-based, but with database in-memory, we actually allow you to use both. And so we populate data in a pure in-memory columnar format in the column store. By default, we compress at mem compress or query load. We typically get anywhere from a 2x to 20x compression rate. We have multiple levels of compression. As I said, it's available on all hardware platforms, but the in-memory part of this says that if the database were to go down, that data is gone. So we'll have to repopulate when the data starts. But the great thing about that is that we don't generate any undo or redo because since the data is not persistent, there's no reason to have undo or redo generation. There's no on-disk format for the columnar format. It's all maintained in the row store. When you allocate the in-memory underscore size parameter, we actually allocate the column store in the SGA along with the other things like the buffer pool or the buffer cache, the shared pool. And so we preserve the Oracle database architecture. We haven't changed anything as far as how Oracle database runs. Still runs the same. DBAs don't have to know anything different really. It's just another area within the SGA where we store the columnar formatted data. One of the things to mention about populating objects in the column store is that the column store is not a cache, it's a store. So when you alter a table to be in memory, the data will be populated in columnar format, compressed. We'll put in-memory storage indexes on that data, and it will be in the column store for its entirety. We won't swap it out. We don't cache it out like we do the buffer cache. So it'll be there until either the instance goes down or we do an alter table no in memory. Where can you get more information? So I've gone through this very quickly. There's way more to database in-memory. Of course, you really don't have to know all of that because all you have to do is enable your objects for in-memory and let your applications make use of it. But the devil's in the details, and so you can get more information on our blog website. We have the URL here, DBIM resources page. In addition to that, I've included some links here for the same types of information, the blog, the resources page, where you can get hopefully most of your questions answered. Don't forget the documentation. We have our own in-memory guide in the Oracle documentation, and that can walk you through a lot of the features available. And hopefully you've enjoyed this, and talk to you later.